Tonight, if you step outside and look up, you will see a few thousand stars. Behind them, unseen, our galaxy holds a few 100 billion more, and beyond it lie 2 trillion other galaxies, each with hundreds of billions of suns of their own. Most of those stars are older than ours by billions of years, and around a great many of them circle worlds, rocky, temperate, patient worlds, with oceans and time to spare. By every reasonable measure, that sky should be crowded with voices. It should be roaring, and yet every instrument we have ever built, pointed in every direction, comes back with the same report. Silence. Complete, unbroken silence. But here is what that silence leaves out. It is not one mystery. It is 10. 10 serious theories, each one explaining the quiet perfectly, and they cannot all be true. Some say we are alone, some say we are being watched, and a few say the silence is a warning about what is already coming for us. Get comfortable. Hit subscribe if you're new here. Because by the end of this, the silence of the night sky is going to sound less like an empty universe, and more like the most important message we have never learned to read. Now let's slowly ease into this. Part 1. The Question at Lunch. On a warm afternoon in the summer of 1950, 4 physicists walked across the grounds of the Los Alamos Laboratory in New Mexico, heading to lunch. They were among the sharpest minds of their generation. One of them was Enrico Fermi, the man who had built the world's first nuclear reactor under a squash court in Chicago. As they walked, the conversation turned, half in jest, to flying saucers, to the newspaper reports of strange lights in the sky, and to whether anything could ever really cross the enormous gulfs between the stars. They laughed about it, sat down, and let the talk drift to other things. Then, in the middle of the meal, with no obvious prompting, Fermi looked up and asked a question that has never really been answered. He said simply, "Where is everybody?" Everyone at the table understood exactly what he meant, and the reason they understood is the reason we are here tonight. Fermi was not asking about the people in the room. He was asking about the universe. He had done, in his head, in the time it took to lift a fork, a piece of arithmetic that leads somewhere genuinely strange, and once you have followed that arithmetic yourself, the night sky never looks quite the same again. Let me walk you through the same short calculation, slowly, the way he would have. Our galaxy, the Milky Way, contains somewhere between 100 billion and 400 billion stars. That is not a number the human mind can truly hold, so let me make it smaller for a moment. If you tried to count the stars in our galaxy 1 per second, without ever sleeping or stopping, you would still be counting after 3,000 years. And our galaxy is only one among roughly 2 trillion galaxies in the part of the universe we can see. The stars are not rare. They are the most ordinary thing in existence. Most of those stars are older than our Sun. The universe itself is about 13.8 billion years old, and our Sun and Earth are only about 4.6 billion years old. That means that for something like 9 billion years before our planet even formed, stars were being born, planets were cooling, and oceans, on worlds we will never see, were presumably doing whatever oceans do. If intelligent life is possible at all, then somewhere out there some of it had a head start on us, measured not in centuries but in billions of years. Here is where Fermi's arithmetic turns cold. Imagine a single civilization, somewhere in that immense stretch of time, that learned to build a ship capable of crossing to a nearby star, not at the speed of light, nothing so exotic, just a slow, patient crawl at a small fraction of it. Imagine that ship carries the ability to build copies of itself when it arrives, using the raw material it finds waiting there. Each new world becomes a shipyard. Each shipyard launches more ships. The expansion doubles and doubles again, spreading outward like a slow tide. When you run the numbers, a single civilization doing this could visit every star in the galaxy in something like a few million years. Against the age of the galaxy, a few million years is almost nothing. It is the last inch of a very long road. So the galaxy should have been crossed, not once but many times over, by many different civilizations, across billions of years of opportunity. The Milky Way should be full of footprints, and when we look, we find none. No ships, no signals we can confirm, no engineering on the scale of stars, no message waiting in the sky, nothing. That gap, between what the arithmetic demands and what we actually observe, is what we now call the Fermi paradox. And a paradox is a specific kind of problem. It is not simply a mystery, a thing we have not yet gotten around to solving. It is a place where two things we are fairly sure are both true seem to flatly contradict each other. The universe should be crowded. The universe appears empty. Both cannot be simply true, which means one of our assumptions somewhere is wrong, and we do not yet know which one. People have taken this seriously for a long time now, and they have tried to pin it down with real tools. In 1961, the astronomer Frank Drake sat down before a small meeting in Greenbank, West Virginia, and wrote out what is now called the Drake equation. It is not really an equation that gives you an answer. It is more like an honest way of organizing your ignorance. You multiply together the rate at which stars are born, the fraction of those stars with planets, the fraction of planets that could support life, the fraction where life actually begins, the fraction where it becomes intelligent, the fraction that builds technology we could detect, and finally how long such a civilization lasts before it falls silent. Feed in hopeful numbers, and the equation tells you the galaxy holds millions of voices. Feed in cautious numbers, and it tells you there is exactly one. Us. The terrible honesty of the Drake equation is that, more than 60 years later, we still cannot agree on almost any of the numbers you put into it. A few years after that, in 1964, a Soviet astronomer named Nikolai Kardashev proposed a way of ranking civilizations, not by how clever they are, but by how much energy they can command. A Type 1 civilization controls the energy of an entire planet. A Type 2 harnesses the full output of its star. Imagine catching every particle of light a sun pours out day and night for billions of years. A Type 3 commands the energy of an entire galaxy. By this measure, we do not even reach Type 1 yet. We are somewhere around Type 0.7, a species still learning to manage the power of the single planet it lives on. And the unsettling thing is this. A Type 2 or Type 3 civilization would be almost impossible to hide. The waste heat alone, the simple warmth of that much machinery, should glow across space in a way our telescopes could pick out. We have looked at hundreds of thousands of galaxies for exactly that glow. We have not found it. In 1975, an astronomer named Michael Hart wrote a careful, sober paper making a point that many people found hard to accept. He argued that the simple fact that there are no aliens on Earth right now, no colonies, no ruins, no artifacts, was itself a powerful piece of evidence. If they existed and could travel, he reasoned, they would already be here, because they have had more than enough time. Their complete absence, he suggested, might mean that we really are alone, at least in our galaxy. Not everyone agreed, but he had turned the silence from a vague feeling into a formal problem that demanded an answer. For a long time, you could at least comfort yourself with the thought that maybe the planets were not there, that stars were common but worlds like ours were rare, and that most of those countless suns burned over empty space with nothing circling them. That comfort is gone now. In 1995, astronomers confirmed the first planet orbiting another sun-like star, a strange hot world called 51 Pegasi b, and the discovery cracked something open. In the decades since, using space telescopes designed to watch for the tiny dimming of a star as a planet crosses its face, we have confirmed thousands of worlds, and we have learned something that would have astonished earlier generations. Planets are not rare at all. They are ordinary. On average, it appears most stars have planets, which means that the number of worlds in our galaxy is not in the millions or billions, but likely runs to the hundreds of billions, and a meaningful fraction of them are rocky and temperate, and sitting in the gentle zone where water could pool on the surface and stay. Let me make that concrete, because it is the fact that gives the whole paradox its edge. Consider standing under a dark sky far from any city, the kind of sky where the stars are so thick they seem to smoke. Nearly every point of light you can see is a sun, and around a great many of them, we now believe, there are worlds. Some of those worlds are almost certainly the right size, at the right distance, made of the right stuff, with liquid water and steady warmth and billions of years of quiet time. The raw ingredients are everywhere. The stage is set over and over hundreds of billions of times across our galaxy alone, and the play, as far as we can hear, is being performed to an empty house. That is the shape of the thing. It is not that the universe lacked the opportunity to fill with life. It is that it had every opportunity more than we can count, and the result is silence. And there was one moment, just one, that seemed as if it might be the beginning of an answer. On the 15th of August 1977, a radio telescope in Ohio nicknamed the Big Ear was quietly scanning the sky, printing its results as columns of numbers on long sheets of paper. A volunteer named Jerry Eman was going through those printouts a few days later. Most of what the telescope hears is a low, formless hiss, the ordinary murmur of the cosmos. But on one sheet, Eamon's eye caught a sequence that leapt off the page, a signal that rose sharply, held for 72 seconds and fell away, exactly the shape you would expect from a fixed point in the sky sweeping through the telescope's view. It was narrow, focused, and strong, sitting near a frequency that many scientists had long guessed an alien broadcaster might choose. Eamon circled the numbers in red pen and wrote a single word in the margin, the word that gave the event its name for all time. He wrote, "Wow." For a few days it must have felt as if the great question had finally cracked open. But the signal never came back. They pointed the telescope at that patch of sky again and again, for years, and heard only the hiss. To this day, no one has fully explained what the wow signal was, and no one has ever repeated it. It hangs in the record like a knock on a door that, when you open it, reveals an empty hallway. So this is where we stand. The stars are countless. The time has been immense. The arithmetic says we should have company, loud and obvious and everywhere, and yet every instrument we have ever built comes back with the same report: silence. The rest of this video is about that silence, and about the fact that it is not a simple thing. We tend to hear silence and think of it as emptiness, as nothing, as the absence of anything to worry about. But over the last half-century, scientists and thinkers have proposed something like 10 serious explanations for the Great Silence, and here is the part that should keep you listening. They do not agree with one another. Some of them say the silence means we are alone, some say it means we are being watched, some say it means we are being hunted, and a few of them say it means something is coming for us that has already come for everyone else. The silence never changes. What changes is what we are willing to believe it is telling us. We're going to count them down, from 10 to 1, and they get stranger and closer to home as we go. By the time we reach the first one, Fermi's simple lunchtime question is going to sound very different than it does right now. Because the real question was never only where is everybody. The real question, the one hiding underneath it, is what happened to them, and whether the same thing is waiting to happen to us. Part 2. The miracle that happened once. The gentlest answer to the Great Silence is also, in a strange way, the loneliest. It begins with a possibility that sounds almost hopeful. Maybe the reason we hear nothing is not that something went wrong out there, but that there was never anyone to hear in the first place. This is the 10th theory on our countdown, and it has a name that captures it perfectly. It is called the Rare Earth Hypothesis. The idea was laid out in detail in the year 2000, in a book by two scientists at the University of Washington, a paleontologist named Peter Ward, who studies the history of life written in rock, and an astronomer named Donald Brownlee, who studies the cosmos overhead. They came to the question from opposite ends, and they arrived at the same uncomfortable conclusion. Their argument was not that life is rare. In fact, they suspected that simple life, bacteria, single cells, the kind of slime that coats a wet stone, might be scattered generously across the universe, springing up wherever there is warmth and water and the right chemistry. What they argued is that the leap from that simple slime to a creature that can look up, wonder, and build a radio telescope is not one leap but a long chain of them, and that nearly every link in the chain requires a run of luck so specific that most worlds never complete it. Let me walk you through some of those links, because when you lay them out one after another, you start to feel the weight of what they are saying. Consider the star first. Our sun is a steady, patient kind of star. It has burned at almost the same brightness for billions of years, and will keep doing so for billions more, and that long stability is exactly what complex life seems to need. Many stars are not like this. Some flare violently, drenching their planets in radiation. Some are so large they burn through their fuel in a few million years and die before life could get comfortable. Some come in pairs and triplets, their gravity yanking any planets into wild, scorching, freezing orbits. A calm, single, long-lived star is not the rule. It is a fortunate exception, and we happen to circle one. Then consider where the planet sits. There is a narrow band around any star, sometimes called the habitable zone, where a world can hold liquid water, not so close that the oceans boil away, not so far that they freeze solid forever. That band is thinner than most people imagine. Move the Earth a little closer to the Sun, and it could become a runaway furnace. Move it a little farther, and it could lock into permanent ice. We are parked in the narrow strip where water can stay liquid for billions of years, and liquid water, as far as we can tell, is the workshop where the chemistry of life gets done. But a good star and a good orbit are only the beginning. Look up at the moon tonight and consider that it may be one of the reasons you exist. Our moon is enormous compared to our planet, far larger, relative to its world, than any other moon in the solar system. It acts like a great steadying hand on the Earth, holding the tilt of our axis nearly constant over immense stretches of time. Without it, that tilt could wander wildly, sending the planet lurching through savage swings of climate that would make the slow, stable evolution of complex creatures nearly impossible. And that moon, we think, was born from a single catastrophic collision early in the Earth's history, when another young planet struck ours a glancing, world-shattering blow, changed the angle of that ancient impact, and there is no moon, and perhaps no us. The chain keeps going. Beneath your feet, the Earth's crust is not a single fixed shell, but a set of enormous plates, grinding and sliding over the hot interior. This restless geology, called plate tectonics, does something quietly essential. It acts like a thermostat for the whole planet, pulling carbon out of the air and burying it, then breathing it back out through volcanoes, keeping the temperature within livable bounds across billions of years. As far as we know, Earth is the only planet where this particular machinery runs. Turn it off and the climate has no way to correct itself, and the long, patient project of building complex life may never survive its first serious stumble. And there is the matter of what guards us. Far out in the cold, the giant planet Jupiter circles like a great shepherd, its immense gravity catching or flinging away many of the comets and asteroids that might otherwise come plunging toward the inner worlds. It is not a perfect shield. Things still get through, and some impacts in Earth past were devastating. But on balance, a large outer planet in the right place seems to reduce how often a world gets battered. Too many impacts too often, and life never gets the uninterrupted stretches it needs to grow complicated. Even the neighbourhood matters. Our solar system sits in a relatively calm suburb of the Milky Way, out along one of the spiral arms, away from the crowded, violent core where stars are packed close together and exploding stars sterilize whole regions with bursts of radiation. Push our address inward, toward the bright centre, and the sky becomes a far more dangerous place to try to keep a fragile biosphere alive for billions of years. There is one more link that deserves its own moment, because it is the one we understand least and may need most, and that is the origin of life itself, the very first step from chemistry that is merely complicated to chemistry that is alive. On Earth, as far as we can tell from the rocks, life appeared remarkably early, almost as soon as the planet had cooled enough to hold oceans. Some people take that speed as encouraging, a sign that life springs up readily wherever it can. But the rare Earth argument offers a colder reading. We have exactly one example. A single instance tells you almost nothing about how likely something is. A coin that lands heads once has not shown you the odds. It is entirely possible that the birth of life is a fluke so improbable that it happens on one world in a galaxy, or one world in 1,000 galaxies, and that we simply cannot tell, because the only planet we can study from the inside is the one where it happened to work. The speed of it here proves nothing about its rarity out there. And then, even granting life its start, there is the step that on our own world took the longest of all, the leap from simple cells to complex ones, the kind of intricate compartmented cells that all plants and animals are built from. On Earth, that leap seems to have happened only once, after more than 1 billion years of nothing but simple life sitting in the seas. For over 1 billion years this planet was alive and going nowhere, a world of slime and single cells with no bodies, no minds, no motion toward anything we would recognize. If that transition is as hard as its single, slow occurrence suggests, then it may be one of the great walls that life almost never climbs, a bottleneck that leaves most living worlds forever microbial, forever silent, forever just short of becoming anything that could wonder about the sky. Now stack all of those together, a stable single star, a precise orbit, a great stabilizing moon born from a lucky collision, a planet-wide thermostat of shifting crust, a giant guardian in the outer dark, a quiet corner of the galaxy, and running through all of it, the one ingredient you cannot rush: time. Billions upon billions of years of relative calm, long enough for life to crawl from single cells to complex bodies to minds. The rare earth argument is that each of these is a filter, and that a world must pass through every single one of them to produce something like us. Miss any one, and you might still get a planet covered in bacteria, sitting there for eternity, alive but never awake. If that is true, then the silence makes a sad and simple sense. The galaxy could be teeming with life, oceans of microbes on 1 billion worlds, and still be almost perfectly quiet, because life that never becomes complex never builds a transmitter, never sends a signal, never leaves its planet. The universe would be full of gardens and empty of gardeners. We would not be alone because something drove everyone else away. We would be alone because the road from slime to a mind is so long and so narrow that, in this whole immense galaxy, it may have been walked to the end exactly once. I want you to sit with what that would actually mean, because it is easy to say, we might be alone, and let the words slide past. Take it seriously. It would mean that everything you have ever found beautiful about being alive, a piece of music that stops you where you stand, the face of someone you love, the simple fact that the universe has, through you, opened an eye and looked at itself, exists in this galaxy nowhere else. Every poem, every act of kindness, every question ever asked about the stars, all of it, a single flame in an enormous dark house, and no other candle burning in any window. That is not a comforting kind of specialness. It is the kind that comes with a terrible weight, because a thing that exists only once is a thing that can be lost only once, and then it is gone from everywhere at the same time. The rare earth hypothesis is the gentlest theory we will discuss tonight, because it contains no hunters, no watchers, no traps. But do not mistake gentle for reassuring. It leaves us standing in an immense, patient, indifferent universe, the only ones who know we are here, carrying something irreplaceable and not entirely sure we know how to keep it safe. And yet, for all its weight, this theory rests on an assumption we should question, the way this channel always questions the comfortable version of things. It assumes that if intelligent life were possible elsewhere, it would already have appeared by now, somewhere in that immense stretch of time. But what if that assumption is wrong? What if life is not rare at all? What if the reason the sky is silent is not that we are the only ones who ever made it, but that we are among the first? What if the party is real, the guests are coming, and we simply arrived while the hall was still empty? That is the 9th theory, and it turns the loneliness of rare earth into something even stranger. Part 3. The Ones Who Came Early. There is a version of the silence that has nothing to do with rarity, and it turns on a single word: early. The 9th theory suggests that the reason we look out and see no one is not that no one is coming, but that we are near the front of the line. We may be among the firstborn, one of the earliest civilizations to open its eyes in a universe that is only just beginning its long age of life. To feel why anyone would suggest such a thing, you have to let go of a quiet assumption most of us carry without noticing. We tend to picture the universe as old and settled, a place with a distant beginning and a comfortable middle, and we imagine ourselves as latecomers arriving well after the interesting part. But the astronomer Abraham Loeb and his colleagues pointed out, in work around 2016, that this picture may be almost exactly backward. When you ask how long the universe will remain capable of supporting life, the answer is staggering. It is not measured in the 13 billion years that have already passed. It is measured in trillions of years still to come. The reason is the kind of star most of the universe actually favours. Our sun is a fairly large, fairly bright star, and stars like it burn hot and fast, lasting only about 10 billion years before they swell, shed their outer layers, and die. But the most common stars in the cosmos are not like the sun. They are small, cool, dim red stars and red dwarfs, and they are misers with their fuel. Where the sun will last 10 billion years, a red dwarf can burn steadily for tens of billions, even trillions of years, a slow ember glowing long after every star like our own has gone dark. If life can take hold around stars like these, and we genuinely do not yet know whether it can, then the great age of a life in the universe has barely started. We are not near the end of the story. We are somewhere in the first sentence. Think of it this way. Imagine the full lifespan of a life-bearing universe stretched out as a single calendar year, from the 1st of January to the 31st of December, where December holds the last of the dying red dwarfs trillions of years from now. On that calendar, everything that has happened so far, every star you've ever seen, the birth of the Earth, the whole history of life on our planet, all of human civilization, takes place in the first few minutes after midnight on the 1st of January. We are not the guests who showed up late to the party. We are the ones who arrived so early that the hall is still empty. The lights are only just coming on, and almost no one else has walked through the door yet. If that is the truth of our situation, then the silence is not sad and it is not sinister. It is simply the quiet of an early morning before anyone else is awake. There is no one answering our signals because there is scarcely anyone yet to answer. The great galactic conversation that Fermi imagined already in full swing may be a conversation that has not started, because we are one of the very first to learn how to speak. To feel how early we might be, it helps to think about what the universe had to do before a planet like ours was even possible. The very first stars were made of almost nothing but hydrogen and helium, the light elements forged in the first minutes after the Big Bang. But you cannot build a rocky planet or a living body out of hydrogen and helium alone. You need carbon and oxygen and iron and all the heavier elements, and those were not present at the beginning. They had to be manufactured slowly inside generations of stars, cooked in their cores and then scattered across space when those stars died. It took billions of years of stars living and dying and enriching the cosmos with their ashes before there was enough of the heavy stuff lying around to assemble a world like Earth, with a molten iron core and a crust full of the elements life requires. We are, quite literally, made of the debris of dead stars, and there simply was not enough of that debris to make us until the universe was already most of the way to its present age. So in a sense, we could hardly have come much earlier than we did. The ingredients were not ready. But the ingredients will keep being made for a very long time to come, and the small red stars that will still be shining trillions of years from now are only now, in cosmic terms, getting their planetary systems settled and warmed. If life needs time, and everything about our own history says it needs a great deal of it, then the worlds that will host the universe's great flourishing of life may not even have finished forming yet. We would not be late to that flourishing. We would be its distant, half-forgotten prologue, the strange early chapter that later life, if it ever looks back, can barely make out. Now, this channel has spent a full evening before on this idea alone, on what it means that we might be the first, so I will not retrace every step of it here. But I want to draw out the one thread that matters most for tonight, because it changes the emotional colour of everything. Being first sounds, at first, like an honour. We would be the elders, the ancient ones, the founders. But turn it over in your hand and feel the other side of it. If we are among the first, then there are no elders above us. There is no ancient civilization that has already faced the dangers we are about to face and left behind a warning. There is no wise voice in the sky to tell us which mistakes are fatal. There is no one who has gone before. Everything that intelligent life will ever become in this galaxy, every triumph, every catastrophe, every hard-won lesson about how to survive your own power, is still ahead, unwritten, and some of the earliest pages may have to be written by us. That is a different kind of loneliness than the rare earth kind. It is not the loneliness of being the only one who ever existed. It is the loneliness of being the one who has to go first into the dark, with no footprints ahead to follow, knowing that whether the ones who come after inherit a galaxy full of life or a galaxy full of silence may depend in part on whether we survive our own beginning, and there is a vertigo hidden in it too. If we are the firstborn, then we are the mystery. Picture a civilization arising 1 billion years from now, around some patient red star, looking out at their sky and asking Fermi's question in their own language, where is everybody? And the answer, unknown to them, is that some of the everybody they're searching for was us, long ago, at the very dawn of things. We would be the ancient silence in someone else's sky, the empty chair at their table. We spend our nights wondering who came before us, and it may be that the honest, dizzying answer is, no one did. We are what before looks like. There is a quiet responsibility folded into this that I think is worth sitting with, because it changes how the theory feels from something frightening into something almost solemn. If we really are among the first, then we are not only the ancient ones for whoever comes later. We are, in a sense, the ones who set the example, the founding act that the future may build on or recoil from. Every choice we make now about how a young civilization handles its own power, its own knowledge, its own capacity to help or to harm, is a choice made without precedent, and it may leave ripples that travel far. Not because anyone is watching us, in this theory, but because we are early enough that what we do could shape the character of the galaxy's whole long age of life, the way the first settlers of a place leave a mark on everyone who follows. That is a heavy thing to carry, and no one handed it to us on purpose. It simply comes with being early. And there is a comfort hidden in it too, if you look for one, which this channel always tries to do even in the darker corners. The firstborn theory is the one theory tonight that contains no threat at all. No hunters, no watchers, no wall. It says the sky is silent for the most innocent reason imaginable, that the guests simply have not arrived yet, and that the universe's great age of company is not behind us, lost, but ahead of us, still coming. In that reading, the loneliness we feel when we look up is not the loneliness of the last ones left. It is the loneliness of the first ones awake, in a house where, eventually, everyone else will rise. We are not at a funeral, we are at a dawn, and dawns are only lonely because the day has not started yet. So the firstborn theory takes the loneliness of rare earth and does something peculiar with it. It says the universe is not empty because life failed. It is empty because life has not yet arrived, and we are the strange, premature exception. Awake in the small hours, the first light in the house, with no one to call and nothing to do but decide on our own what kind of ancestors we are going to be. But notice that both theories so far share one thing. They both assume the sky is honest, that when we look out and see no one, it is because there truly is no one there to see, whether they never existed or have not yet arrived. What if that assumption is the mistake? What if the reason the sky looks empty is not that it is empty, but that someone has decided we are not ready to know what is really out there? That is where the countdown takes its first turn towards something colder, and it is the eighth theory, the possibility that we are not alone at all, and never have been. Part 4. The Preserve. Consider how a park ranger watches a herd of deer. The ranger knows the animals intimately, counts them, tracks them, understands their lives in detail. The deer, meanwhile, have no idea the ranger exists. They graze, they raise their young, they live and die inside a preserve whose boundaries they cannot perceive, and whose keeper they will never meet. From the deer's side, the forest is simply the whole world, wild and unwatched. From the ranger's side, it is a managed place, observed from a careful distance, deliberately left undisturbed. The eighth theory on our countdown asks a single unsettling question. What if we are the deer? This idea has a name, the zoo hypothesis, and it was set down in 1973 by a radio astronomer named John Ball. His reasoning was simple and hard to shake. We keep assuming that the silence means absence, that hearing nothing means no one is there. But there is another way to hear nothing. You hear nothing when someone who is there has chosen very deliberately to be quiet. Ball proposed that the Milky Way is not empty but inhabited, that advanced civilizations do exist, do know about us, and have simply agreed to leave us alone, watching from a distance the way we might watch animals in a preserve we have set aside and promised not to disturb. Once you take the idea seriously, it starts to explain the very thing that makes the Fermi paradox so sharp. Remember the problem. A civilization far older than us should have spread across the galaxy long ago, and we should see it everywhere. The zoo hypothesis accepts all of that. Yes, it says, they spread. Yes, they are old and capable and probably all around us. The reason you do not see them is not that they are absent. It is that a civilization advanced enough to fill a galaxy is also advanced enough to decide, as a matter of principle, not to trample the young worlds it finds along the way. Perhaps they remember what it cost them to grow up on their own. Perhaps they have learned that a species which is handed the answers never truly becomes itself. So they hold back. They let us develop untouched, unaware, believing the room is empty, until we cross some threshold, some level of maturity or wisdom, or simple survival, that would qualify us to be told the truth. Now, I want to be careful and honest here, the way this channel always tries to be. The zoo hypothesis has a real weakness, and thoughtful people have pointed it out. For it to work, the silence has to be perfect. Not one civilization, not one individual, not one faction across the entire galaxy and across millions of years can break the rule and reach out to us. All it would take is a single exception. One curious visitor, one broken agreement, one signal sent by someone who disagreed with the policy, and the illusion shatters. Keeping an entire galaxy quiet without a single leak for ages is a staggering thing to ask. That difficulty is exactly why the zoo hypothesis remains a possibility and not a proven fact. A concealment that complete is very hard to believe, and awkwardly just as hard to disprove. But set the weakness aside for a moment and let yourself feel the full strangeness of what it would mean if it were true, because the emotional weight of this theory is not in the watching, it is in what the watching does to everything else. If the zoo hypothesis is right, then the privacy you have assumed your whole life, the sense that humanity's story is unwitnessed, that we struggle and stumble in an indifferent universe with no audience, is an illusion. Everything we have ever done has been seen. Every war, every discovery, every quiet act of decency in an empty room, not by a god, in the old sense, but by minds, real, physical, immensely old minds who made a choice about us before any of us were born and have been keeping to it ever since. And there is something even more disorienting underneath that. If we are inside a preserve, then our sense of freedom might be in part a thing that has been allowed. We tell ourselves that history is ours to make, that our choices are our own, that no one is steering. But a preserve has a fence, even if the deer never find it. There may be lines we cannot cross that we have simply never happened to walk up against, a signal we could never quite complete, a discovery that always seems to slip just out of reach, a door that has been quietly held shut. We would experience all of that as ordinary difficulty, as the natural resistance of a hard universe. We would never know the difference between a wall that is there by nature and a wall that is there by decision. There is a gentler version of this idea worth pausing on, because not every reading of the zoo hypothesis is sinister, and honesty means holding the kind possibilities alongside the frightening ones. Perhaps the silence is not containment, but courtesy. Think of how carefully a good teacher steps back from a student who is on the edge of understanding something, resisting the urge to blurt out the answer, because they know that the understanding will only be real if the student reaches it alone. A civilization that had watched younger species before ours might have learned, through long and perhaps painful experience, that contact made too early does more harm than good, that a young world handed the science and the philosophy of its elders before it was ready does not become wiser, only dependent, its own hard-won character never given the chance to form. Under that reading, the silence is a kind of respect. They are not caging us. They are giving us room. They are letting us become whoever we are going to become, in our own time, by our own effort, so that when the introduction finally comes, we meet them as ourselves and not as students who never had to think. But even that gentle version has a shadow, and the shadow is the same one that falls across every form of the zoo hypothesis. It is that the decision was not ours. Whether the watchers are wardens or teachers, jailers or guardians, the fact remains that our situation was chosen for us by minds we cannot see, according to a plan we were never shown, for reasons we are not permitted to evaluate. Kindness we did not consent to is still a kind of control, and a preserve, however lovingly it is managed, is still a place with an edge that its inhabitants are not allowed to find. I said a moment ago that we might be the deer, and I want to return to that because the comparison cuts deeper the longer you hold it. The deer are not mistreated. The ranger may love them. The preserve may be the safest place they could possibly live. And still there is something in us that recoils at the thought of being on the animal side of that arrangement, of being cared for without being consulted, observed without being asked, kept in a comfortable enclosure whose existence we are not permitted to know. The zoo hypothesis does not threaten us with harm. It threatens us with something subtler and, for a certain kind of mind, worse. The possibility that our independence is a courtesy, extended by others, that could in principle be withdrawn. Think too about how the zoo hypothesis handles the very objection that seems to sink it. We keep tripping over how hard it would be to keep an entire galaxy quiet, without a single break in the silence, across ages of time. But consider that the same advanced civilization capable of watching us is presumably capable of enforcing its own agreements, of making sure that no faction, no rogue, no curious individual breaks the quarantine. What looks to us like an impossibly fragile conspiracy might to them be a simple and stable rule, maintained as easily as we maintain the boundaries of a nature preserve, with the added advantage that the animals inside have no idea there is a rule at all. The difficulty we feel in believing the silence could be perfect may say more about the limits of our own coordination than about theirs. We cannot imagine keeping a secret that large. That does not mean minds far older and far more unified than ours could not. And there is a version of this that is almost tender and worth naming before we move on. Some who have thought about the zoo hypothesis suggest that the threshold for contact might not be technological at all, not a matter of building the right telescope or reaching the right level of energy, but moral. Perhaps we're being left alone until we stop being a danger to ourselves, until we learn to manage our own power without turning it against one another, until we grow into the kind of species it would be safe and worthwhile to speak to. In that reading, the silence is not a cage and not a courtesy, but a patient waiting, the universe holding its breath to see whether we'll grow up and staying quiet until we do. It is a strange thought, that the reason the sky says nothing might be that we have not yet earned the conversation. This is the moment in our countdown where the silence stops being a simple fact about an empty sky and becomes a fact about a decision. Under rare earth, no one was there. Under the firstborn theory, no one had arrived yet. But under the zoo hypothesis, they are here, and the quiet is not nature. It is policy. Someone chose it. Someone maintains it. And the silence you hear when you look up is not the sound of an empty universe. It is the sound of a room full of people who have all agreed not to speak while you are listening. But here the theory has one more door to open, and it is the darkest yet. The zoo hypothesis assumes that even if the aliens stay hidden, at least the stars themselves are real, that we are being kept from meeting our neighbours, but not deceived about the universe we live in. What if that final comfort is also false? What if a civilization that wanted to keep us convinced we are alone would not simply stay quiet, but would take control of what we are allowed to see? That is the seventh theory, and it turns the sky itself into something we can no longer trust. Part 5. The Wall of Stars. Everything we know about the universe reaches us as a signal. The light of a distant star, the faint warmth of the cosmic background, the crackle of radio from across the galaxy. All of it arrives as information, gathered by our eyes and our instruments and assembled inside our heads and our computers into a picture of what is out there. We trust that picture because we have no reason not to. But there is a question buried in that trust, and the seventh theory picks it up and refuses to put it down. If everything we know arrives as a signal, then what happens to our knowledge if someone is in control of the signal? This is the planetarium hypothesis, and it was set out in the year 2001 by the writer and engineer Stephen Baxter, who took the zoo hypothesis and pushed it one merciless step further. The zoo hypothesis says the aliens stay quiet. The planetarium hypothesis says that staying quiet is not enough. If an advanced civilization truly wanted to keep a young species convinced that it was alone, it would have to do more than simply refrain from sending signals. It would have to manage the absence of signals. It would have to make sure that when we pointed our telescopes at the sky, we saw exactly the empty, silent universe we expected to see, and nothing that would give the game away. Picture the old-fashioned planetarium, the domed room where you lean back in your seat and a projector paints the night sky onto the ceiling above you. The stars look real. The constellations wheel overhead. For as long as you are inside, that painted dome is your entire sky. Baxter's proposal is that a sufficiently advanced civilization could, in principle, build something like that around us. Not a literal dome, but a controlled bubble of information, a carefully maintained illusion of an ordinary empty cosmos, projected inward at whatever radius our instruments can currently reach. We would look out and see stars, galaxies, silence, and all of it, out to the edge of our vision, would be a show. The remarkable thing about Baxter's paper is that he did not just wave his hands at the idea. He tried to estimate the cost. How much energy, how much engineering would it take to fake the sky convincingly out to a given distance? The answer, unsurprisingly, is enormous, far beyond anything we could dream of. But, and this is the point that should make you sit up, it is not infinite. For a civilization at the upper end of the Kardashev scale, a Type 2 or Type 3 commanding the energy of stars and galaxies, the number, though gigantic, is not impossible. The illusion is expensive. It is not forbidden by physics. And as our instruments improve and our bubble of vision grows, the deception would simply have to grow with it, which Baxter noted gives us a strange and slender hope. Keep looking harder, keep pushing the edge outward, and eventually you might reach a radius the projectionist cannot afford to maintain, a place where the seam shows. I want to be clear-eyed about this, because it is the kind of idea that can tip over into paranoia if you let it. The planetarium hypothesis is a close cousin of a broader idea you have probably heard, the notion that our whole reality might be a simulation, And like that idea, it has a slippery quality. It is very difficult, maybe impossible to prove false. Any evidence you find against it can be explained away as simply part of the illusion. That unfalsifiable quality is exactly why careful scientists file it under serious philosophy rather than established fact. It is a possibility to hold at arm's length and examine, not a conclusion to believe. We are exploring it tonight because it is a real proposal made by a serious thinker, and because following it teaches us something true about the limits of what we can know, not because the evidence says the sky's a screen. It helps to remember that we do not actually see most of the universe. We see a very thin slice of it, the particular kinds of light and radiation our instruments are built to catch, and even that reaches us only after crossing immense distances and immense stretches of time. The light from a distant galaxy left it millions or billions of years ago. We are never looking at the universe as it is, only at a patchwork of old messages arriving from every direction at once. Our whole picture of the cosmos is assembled painstakingly from these arriving signals, stitched together into something that feels solid and continuous, but is really a reconstruction, a model built inside our heads and our machines from the light that happens to fall on us. The planetarium hypothesis simply asks what would happen if some of those arriving signals were not authentic, if, somewhere in the long chain between the distant source and our detector, something had edited the message. We would have no way to notice. The forgery would arrive looking exactly like the truth, because for us, the arriving signal is the only truth we ever get. And consider how much easier the deception would be than faking an entire, richly detailed universe atom by atom. The projectionist would not need to build real stars or real galaxies. It would only need to manage what reaches us, to make sure that the particular photons and radio waves landing on our particular instruments carry the particular story of an empty sky. You do not need to build a whole ocean to convince someone there is water on the other side of a wall. You only need to control the single trickle that comes under the door. The scale of what our instruments can actually sample out of the whole overwhelming cosmos is tiny. Managing that trickle for a civilization of sufficient power might be far more modest than it first appears. But follow it we should, because here is what it does to the ground under your feet. Every theory before this one left the universe itself intact. Under rare earth, the stars were real and empty. Under the firstborn theory, the stars were real and young. Under the zoo, the stars were real and inhabited, and we were merely kept from meeting the inhabitants. In every case, we could still trust the sky. We could still say, whatever is going on with the aliens, at least the universe I measure is the universe that is really there. The planetarium hypothesis takes that last handhold away. It suggests that the emptiness we observe might not be a discovery about the universe at all, but a decision made about us, that the silence is not something we found, but something we were shown. Sit with how far down that cuts. The entire human project of understanding the cosmos rests on a single assumption so basic, we almost never say it aloud, that when we look, we see what is truly there. Every equation, every map of the heavens, every hard-won law of physics is built on the faith that the signal is honest. If the signal can be authored, if there is even one civilization capable of editing what reaches our instruments, then the reach of our knowledge no longer ends at the edge of the universe. It ends at the edge of what we are permitted to detect, and we would have no way from the inside to tell those two edges apart. There is a particular loneliness in that, different from anything we have met so far. It is not the loneliness of being the only ones, or the earliest ones, or the watched ones. It is the loneliness of not being able to trust your own eyes, of suspecting that the most careful, honest work you can do, the patient measuring of a quiet sky, might be a test that someone else designed and is standing just out of frame, quietly grading. Under the planetarium hypothesis, the astronomer at the telescope and the child looking up from a backyard are doing the same thing, gazing with complete sincerity at a ceiling and calling it the universe. And yet, even this theory leaves one thing standing. It imagines a keeper who deceives us but does not harm us, a projectionist, patient and hidden, content to let us live inside the show. Every theory so far, however cold, has assumed that whoever is out there means us no direct violence. They ignore us, or watch us, or fool us, but they do not come for us. The sixth theory abandons even that. It asks what happens if the silence is not kept by watchers or projectionists, but enforced, actively, mechanically, and without mercy, by something built for the single purpose of making sure young civilizations like ours never get to grow old. Part 6. The Machines That Hunt. We have already met the idea of a machine that can build copies of itself. Earlier tonight, when we followed Fermi's arithmetic, it was the key to why the galaxy should be full. A single probe that lands on a distant world, gathers raw material, and constructs new probes to send onward, could in a few million years reach every star. It was named after the mathematician John von Neumann, who worked out the logic of self-reproducing machines, and in that first telling it was a tool of exploration, the patient, peaceful way a curious civilization could come to know its galaxy without ever leaving home. The sixth theory takes that same machine and asks a much darker question. What if someone built it not to explore, but to kill? This is the Berserker hypothesis. The name comes from a series of science fiction stories written by Fred Saberhagen in the 1960s, in which ancient automated warships, left over from a long-dead war, roam the galaxy destroying any life they find. But the serious version of the idea was taken up by real scientists, most notably the astrophysicist David Brin, who in 1983 wrote an influential paper cataloguing every explanation for the great silence he could find. Among them was this one, and it is the one that keeps you up at night. Suppose that somewhere, at some time in the long history of the galaxy, a single civilization, out of fear or malice or cold strategy, built self-replicating probes and gave them one instruction: find emerging technological life and end it before it can become a rival. Think about what such a system would do once released. It would spread exactly the way the peaceful probes would spread, doubling and doubling, riding the same slow tide across the stars. But instead of cataloguing worlds, it would be watching for a particular signal, the unmistakable sign of a young civilization waking up, the first radio broadcasts, the first bright artificial glow, the chemical fingerprint of industry in a planet's atmosphere. And when it found that sign, it would act, and then it would move on, and the machines would keep multiplying and keep hunting, patient and tireless, long after the civilization that made them had itself crumbled to dust. That is the coldest part of the idea. A weapon like this would not need its makers to survive. It would not need a reason anymore. It would simply be a process, grinding on across millions of years, sterilizing the galaxy one young voice at a time for a war that ended before our sun was born. If even one such system was ever built, anywhere, in all the ages the galaxy has existed, it could account for the silence completely. It would not matter that life is common, or that civilizations arise again and again. Each one would rise, grow loud, and be cut down before it could spread, and the sky would fall quiet not because no one is there, but because everyone who announced themselves was answered by something that does not talk. And now I need you to feel the specific weight this theory carries, because it is different from all the ones before it. Until this point in our countdown, the silence has been something that happened to us or around us, an emptiness, a policy, an illusion. We were the observers, safe behind our instruments, wondering about a distant universe. The Berserker hypothesis is the first theory in which we are not safe observers. We are potential prey. And worse, we may have already done the one thing prey must never do. Because we have been loud. For roughly 100 years now, since the first powerful radio transmitters, human civilization has been leaking its presence into space. Our broadcasts, our radar, the electromagnetic noise of an industrial world, have been expanding outward in a growing bubble, a sphere of evidence announcing to anything within about 100 light years that a young technological species woke up on this particular pale blue world. We did it without thinking, the way a child shouts in a house it assumes is empty. And if the Berserker hypothesis is right, then that bubble of noise is precisely the beacon such machines are built to detect. A bright, unmistakable flag reading, "Here we are, we have just learned to speak. There is no calling it back. Light does not return. Every old broadcast, every early transmission is already travelling, already beyond our reach, spreading outward at the speed of light in every direction at once. If something is listening, the message has been sent, and the only thing we can do is wait to learn whether anything was there to hear it. That is a genuinely new kind of dread. It is not the dread of an empty universe or a hidden one. It is the dread of having perhaps made an irreversible mistake in our first curious moments of speech, of having drawn a breath to say hello into a dark that may not be as empty or as gentle as we assumed. There is a detail here that makes the berserker idea especially hard to shake, and it has to do with how little it would take to doom everyone. Most of the theories we have discussed require something to be true of nearly all civilizations, that nearly all are rare, or nearly all choose to hide, or nearly all turn inward. The berserker hypothesis needs almost the opposite. It needs only one civilization, at one moment, in the entire history of the galaxy, that decided to build a self-replicating weapon and let it loose. Just one bad actor, one paranoid empire, one dying species that chose to salt the galaxy behind it, and the machines it made would outlive it and keep working forever. When you consider how many civilizations may have risen across billions of years, and how only a single one of them needs to have made this single terrible choice, the odds stop feeling comfortable. It is much easier to believe that everyone was peaceful except one, than to believe that everyone, without exception, was peaceful. And there is a grim elegance to how such a system would choose its moment. It would not waste itself attacking barren rock or lifeless seas. It would wait, patient as only a machine can be, for the one unmistakable sign that a world had crossed the threshold into danger. The sudden blooming of radio noise, the first artificial lights, the chemical signature of industry staining a planet's air. Those are the marks of a civilization that has just acquired the power to eventually reach the stars, and therefore the power to eventually become a rival. In other words, the trigger is not life. The trigger is exactly the stage we reached about a century ago. The machines, if they exist, are not looking for planets. They are looking for the thing we just became. Now, in fairness, and this channel always tries to keep the scales honest. The berserker hypothesis has its critics, and their objection is a reasonable one. If such machines existed and worked as advertised, some argue, they should have long ago converted the entire galaxy into more of themselves, and we would see the evidence of that runaway process everywhere. The fact that the galaxy is not visibly overrun by self-replicating war machines is, to some, a point against the idea. But the reply is unsettling in its own right. A well-designed hunter would not need to be everywhere at once. It would only need to be watching, quietly, at the frequencies that matter, ready to act when a new voice appears. The absence of visible machines is not proof of safety. It may only be proof that the hunter is good at its job, which is to remain unseen until the moment it is needed. It is worth pausing on how ordinary the ingredients of this nightmare are, because that is what makes it more than a story. Self-replicating machines are not magic. We are, in our own clumsy early way, already thinking about how to build spacecraft that could mine an asteroid, and use the material to construct more of themselves. It is one of the most discussed ideas for how a species with our level of technology might eventually explore the galaxy on a budget. The same capability that would let us send peaceful probes to catalogue 1,000 worlds is the capability that, pointed the other way, becomes a weapon that needs no soldiers and no supply lines and never stops. The line between a tool of exploration and an instrument of extinction is not a line of physics. It is only a line of intent, and intent, across the whole long history of a galaxy full of minds, is not something you can count on staying kind. That is the truly disturbing implication, and it reaches back to touch us. If self-replicating probes are within reach of a civilization at roughly our stage of development, and the logic suggests they are, then the danger is not only that someone else built killers long ago, it is that the capacity to build them is a normal milestone, something many civilizations reach, including, before long, perhaps us. The question of why the galaxy is silent starts to blur into a question about what kind of thing we ourselves are on the verge of becoming able to make. A universe that can be sterilized by a single bad decision is a universe where the character of each civilization, at the moment it gains this power, matters enormously, and where we are approaching exactly that moment, with exactly that choice, faster than we tend to admit. So here is where the sixth theory leaves us. The silence is no longer an absence, it is a kill count, and we are standing in the open, having already announced ourselves, waiting to find out whether anything registered the signal. It is a bleak picture, but notice that it still depends on a single ancient enemy, one civilization's terrible decision echoing down the ages. What if the truth is worse than that? What if the danger is not one hidden hunter, but a logic so universal that every civilization, everywhere, arrives at the same conclusion on its own? that the only way to survive is to stay silent and to destroy anyone who does not. That is the fifth theory. It is called the dark forest, and it is the moment this whole picture turns and looks directly at us. Part 7. The dark forest. Let me put you inside it, because this theory is best understood not as an argument but as a feeling, and the feeling is the point. You are standing in a forest at night. It is absolutely dark, so dark that you cannot see your own hands, and you understand that you are not alone. There are others moving through the trees around you, how many you cannot tell. Some may be harmless, some may be hunters, some may be far stronger than you, strong enough to end you without effort or thought. You cannot see any of them, and they cannot see you, and every one of you knows the same terrible arithmetic. If you make a sound, you reveal your position. If you reveal your position, you are gambling your life on the hope that whoever hears you is both willing and able to spare you, and you have no way to know their intentions, no way to ask, no way to trust an answer even if one came. In a place like that, what do? You hold your breath, you make no sound, and if you should hear another creature stumble and give away its position, the safest thing you can possibly do, the coldly rational thing, is to strike it down before it can decide to strike you. That is the dark forest, and it is the fifth theory. It was given its sharpest and most famous form by the novelist Liu Cixin in a 2008 novel that took its name from the image, though its roots run back through earlier scientific thinking, including that same paper by David Brin. And unlike a lone ancient enemy or a single civilization's terrible weapon, the dark forest requires no villain at all. It emerges, all on its own, from cold logic. The same logic, arrived at independently, by every civilization clever enough to think it through. That is what makes it so much heavier than the theory before it. The Berserker hypothesis needed someone to choose cruelty. The dark forest needs no one to choose anything. It only needs everyone to be afraid and to be rational about their fear. Let me lay out the reasoning, because it is unnervingly tight. Start with two facts that are almost certainly true of any civilization anywhere. First, each one wants, above all, to survive. Second, no civilization can ever be sure of another's intentions across the immense gulfs of space, where a single message takes years, centuries, or millennia to cross, and where you can never look the other in the eye. Now add a third fact, the one that turns caution into dread. Civilizations grow. A species that is harmless and primitive today might, given a few centuries, an eye blink on the cosmic clock, undergo an explosion of technology that makes it enormously powerful. So even a neighbor who seems weak and friendly now cannot be trusted to stay weak, or friendly, by the time your warning could reach them, or theirs could reach you. Put those three facts together, and the conclusion is brutal and within its own logic airtight. You cannot afford to reveal yourself, and you cannot afford to let a revealed civilization survive, because by the time you learn whether they were a threat, it may be far too late to do anything about it. Silence is not shyness. Silence is survival. And the ones who are not silent are the reason the forest is so quiet. If this is the truth of our situation, then the great silence is not the sound of an empty galaxy. It is the sound of a galaxy full of civilizations, all of them crouched in the dark, all of them holding their breath, all of them listening, and every one of them understanding the first and most important rule, which is that you do not under any circumstances call out. And now I have to tell you the part that should make you set down whatever you are holding. We called out. For decades, moved by the most beautiful impulse in our nature, curiosity and loneliness, and the ache to know we are not alone, we have deliberately shouted into the forest. In 1974, we used one of the largest radio telescopes on Earth, at Arecibo, to beam a powerful encoded message toward a distant cluster of stars, a message describing our chemistry, our numbers, our world, and ourselves. We attached engraved plaques and golden records to the Voyager spacecraft, and flung them out of the solar system, deliberate messages in a bottle, carrying pictures of human beings and the location of our planet, addressed to whoever might one day find them. And behind those grand gestures, quietly, our ordinary radio noise has been spilling outward for a century, an unintentional announcement no one ever voted on. Every one of those acts was born of hope. Every one of them was, if the dark forest is real, precisely the thing you must never do. Feel the full turn of that. Everything we did to reach out, the messages, the golden records, the patient, hopeful broadcasts. We did believing that being found would be the most wonderful thing that could ever happen to us, that a voice answering from the stars would be a homecoming. The dark forest takes that hope and inverts it completely. It says that in a universe built on this logic, being found is not a homecoming, it is the end. And the kindest, safest, most merciful thing the universe could possibly do for a young and reckless species that has been shouting its location into the dark is exactly the thing it has been doing all along. To not answer, to let the silence hold, to pretend, a little longer, that it did not hear. There is a real scientific argument happening right now, in the open, among serious people, about whether we should ever deliberately send such messages again. It goes by the name of active messaging, and its critics, some of them among the most respected minds in the field, argue that we should stop, that broadcasting our existence to an unknown cosmos is a gamble no one has the right to make on behalf of the entire species. Its defenders argue that the horse has already left the barn, that our noise is already out there, and that hiding now is both futile and cowardly. That argument is not settled. It is one of the few places where the theories we are discussing tonight stop being abstract and start shaping real decisions about what humanity does next. And the reason it is so hard to resolve is that no one knows which forest we are actually standing in, the empty one, where shouting costs nothing, or the full one, where it costs everything. There is a piece of the logic that deserves a closer look, because it is the part that makes the dark forest so much colder than ordinary caution, and it is called, in the reasoning around this idea, the chain of suspicion. Between two people on Earth, distrust can be worked through. You can talk, meet, exchange gestures of goodwill, build a history, and slowly come to believe the other means you no harm. But now imagine trying to build that trust across a gulf so wide that a single sentence takes centuries to cross. You send a friendly message. 400 years later, they receive it. 400 years after that, their reply reaches you. By the time you have exchanged even a few words, empires have risen and fallen on both sides, and neither of you can be sure the civilization you are speaking to is the same one that sent the last message, or that it still feels the way it did when it wrote. Trust needs contact, and contact across these distances is almost impossible. You are left forever guessing at the intentions of a stranger you can never truly meet. And when the cost of guessing wrong is the extinction of everything you love, guessing generously is a luxury no one can afford. Add to that the thing we called the technology explosion, and the trap closes completely. Even if you could somehow confirm that a distant civilization is harmless today, you cannot confirm it will stay that way. A species that is primitive now might, in the few centuries it takes your message to arrive, undergo the same kind of sudden leap in power that we ourselves underwent, going from campfires to starflight in the blink of a cosmic eye. So the neighbour who is no threat when you decide to spare them may be a mortal danger by the time your mercy reaches them. In the dark forest you cannot even afford to be kind to the weak, because weakness is temporary and you will not get a second chance. Every line of reasoning leads to the same bleak door. Reveal nothing, trust no one, and if something reveals itself, act before it can grow. It is not cruelty. It is the mathematics of fear, worked out to its final, airless conclusion. I do not want to leave you only in fear, because honesty runs both ways, and the dark forest is a theory, not a verdict. It rests on assumptions that may not hold. Perhaps advanced civilizations grow not more paranoid, but more secure, more able to defend themselves, less threatened by a young world's chatter. Perhaps the distances that make trust so hard also make attack pointless, since anything you feared could change beyond recognition in the centuries it took your weapon to arrive. Perhaps cooperation, not annihilation, is the stable strategy over the truly long run. There are thoughtful people who believe the forest is not dark at all, only quiet. But the dark forest earns its place high on this countdown because of what it does to our sense of ourselves. It takes the noblest thing about us, our reaching out, and asks whether it was wisdom, or whether it was the innocence of a creature that did not yet know the rules of the place it was born into. So we have moved, step by step, from a universe that was empty, to one that was watched, to one that was hunted, to one where everyone hides from everyone, and the silence is a shared act of survival. Each theory has assumed that the aliens, whatever they are doing, are at least awake, living, acting, choosing, in the same present moment we are. The fourth theory sets that assumption aside in the strangest way yet. It suggests that the greatest civilizations are not hiding and not hunting and not gone. They are asleep, deliberately, patiently asleep, waiting for a universe that has not yet arrived. Part 8. The Sleepers. Some animals, when the season turns against them, do not fight it. They sleep through it. We know about hibernation, the winter sleep, but there is a mirror of it called estivation, the summer sleep, where a creature waits out a season that is too hot, too dry, too hostile for the life it wants to live, and simply lowers itself into stillness until the world becomes kind again. The fourth theory on our countdown proposes that the most advanced civilizations in the universe are doing exactly this, on a scale that beggars the imagination, and that the season they are sleeping through is the present age of the cosmos itself. This is the estivation hypothesis, and it was put forward in 2017 by 3 researchers, Anders Sandberg, Stuart Armstrong, and Milan Cirkovic, working at the intersection of physics and the long-term future of intelligence. It is, I think, the most quietly mind-bending idea we will meet tonight, because it does not rely on fear or malice or accident. It rests on a single, sober piece of physics, and once you understand that piece, the whole strange conclusion follows almost inevitably. The physics is a rule called Landauer's principle, named for the physicist Rolf Landauer, who worked it out in 1961. It concerns the relationship between information and heat, and it says something that sounds abstract but turns out to be profound. Erasing a bit of information, the most basic operation a computer performs over and over trillions of times a second, has an unavoidable energy cost, and that cost depends directly on temperature. The colder the environment, the less energy it takes to process each piece of information. Cold is cheap. Heat is expensive. A computer running in a frigid environment can do far more thinking for the same energy than the identical computer running in a warm one. Now bring in a fact about the universe that we have discussed before on this channel. The cosmos is cooling. Right now, the average temperature of empty space, warmed by the faint afterglow of the Big Bang, is about 2.7 degrees above absolute zero. Very cold by human standards, but not nearly as cold as it will one day be. As the universe expands, that background warmth keeps thinning out, dropping lower and lower across the ages. In the far, far future, not billions but trillions of years from now, space will be colder than it is today by an enormous factor, approaching the absolute floor of temperature itself. Put those two facts side by side, and the conclusion arrives like a key turning in a lock. If you are a civilization that has, over the ages, transformed itself into something essentially made of information, an immense mind, a great computation, its thoughts and memories and experiences all running as processes on some immense engine, then the amount of thinking you can ultimately do is set by how much energy you have and how cold your environment is. And here is the staggering part. Because cold is so much cheaper than heat, a fixed store of energy spent in the profound cold of the far future could buy you enormously more computation, enormously more thought, more experience, more life, than the same energy spent now in the relatively warm and wasteful present. By some estimates, waiting could multiply what you're able to do by a factor so large it is hard to write down. So what would a truly rational, truly patient civilization do? It would not burn its precious energy now in the hot early universe, running its mind at a terrible exchange rate. It would do the thing the summer-sleeping animal does. It would gather its resources, build whatever infrastructure it needed to survive the wait, compress itself down into a dormant, guarded state, and set an alarm for an age trillions of years away when the universe has cooled enough to let it think at full power. It would estivate. It would sleep through the summer of the cosmos, not because it is dying, but because it is being smart, waiting for the cold, quiet, efficient evening of the universe when its stored energy will go so much further. If that is what the great civilizations have done, then the silence makes a new and eerie kind of sense. We hear nothing not because no one is there, and not because they are hiding or hunting, but because the galaxy's most advanced minds are right now deliberately idle, paused, curled around their sleeping infrastructure in the dark, doing as little as possible, spending nothing they do not have to spend, waiting for a future so distant that our entire era, every star now shining, all of human history, the whole warm, bright present, is merely the long, tedious morning they are sleeping through. Let me try to give you a feel for the scale of patience this would require, because it is so far outside anything human that the mind slides off it. We think of a long wait as a lifetime, or a few generations, or at the outside the span of recorded history, a few thousand years. The sleepers in this theory are not waiting thousands of years. They are waiting until the universe itself has aged past every star now burning. They are willing to skip the entire era of shining stars, to sleep through the birth and death of whole galaxies, to let a length of time pass that makes the current age of the cosmos look like a single morning, all to arrive at an evening so cold and so quiet that their stored energy will finally buy them the enormous life they are saving it for. That is not patience as we know it. It is patience raised to a level that has become something else, a strategy so long that it barely fits inside the word waiting at all. And it implies a confidence in their own survival, across spans of time we can hardly write down. That is its own kind of wonder. It also solves a problem that haunts the other theories, which is why we do not simply stumble across the ruins or the leftovers of these great civilizations. Under the estivation hypothesis, there is nothing loud to find, because being quiet is the entire point. The sleepers would have compressed themselves into the smallest, most durable, most efficient form they could, tucked away around the coldest, stablest, most defensible corners they could find, doing nothing that radiates, nothing that announces, nothing that spends. They would look to us like empty space, which is exactly what they want to look like, and exactly what we see. A civilization optimized to survive an unimaginable wait would be, almost by definition, a civilization we could not detect, because every watt spent being visible is a watt stolen from the future they are sleeping toward. And this is where the theory reaches in and touches something cold in the chest, because the emotional weight of it is not fear, it is indifference. Consider what it would mean about our place in the story. It is one thing to be alone, it is another to be watched or hunted. But the estivation hypothesis suggests something almost worse than any of those, that we are not being ignored out of policy or avoided out of caution, but that we simply do not matter yet. The sleepers looked at a universe like ours, young, hot, loud, wasteful, its stars still burning, its cosmos still warm, and decided it was not worth waking for. We are living in the era they found too crude to bother with. Our whole moment, the entirety of what we would call now, is beneath their alarm clock. We are the noise before the morning they actually care about. There is a strange dignity in the idea too if you turn it the other way. It imagines minds so patient that they are willing to skip trillions of years to get a better deal, so certain of the long future that they can afford to sleep through everything we would call history. That is a kind of grandeur our short lives can barely grasp, the confidence to wait longer than every star in the sky will burn. But grandeur seen from below, from inside the era being slept through, feels a great deal like being overlooked. We would be a civilization waving at gods who have set an alarm for an age we will never live to see, and who left standing orders, perhaps, not to be disturbed by anything as small and brief as us. And notice what the estivation hypothesis quietly changes about the whole shape of the countdown. Up to now, every theory has assumed that to be advanced is to be active, to spread, to watch, to hunt, to broadcast. The sleepers break that assumption. They suggest that the mark of a truly advanced civilization might be to do almost nothing, on purpose, for a very long time. That the endpoint of intelligence might not be a galaxy blazing with activity, but a galaxy that has gone deliberately, strategically quiet. If that is true, then we have been searching for the wrong thing all along. We have been listening for noise when the signature of the greatest minds may be their silence. The sleepers are still here, though. They still exist in the present, even if they are doing nothing in it. Their sleeping infrastructure somewhere out there in the dark, waiting. The third theory removes even that. It suggests that the most advanced civilizations have not gone quiet, or gone to sleep, but have gone somewhere else entirely, inward, into a place our telescopes can never point, following the road that every growing intelligence may ultimately be pulled down. Part 9. The Road Inward. We have always assumed that a growing civilization grows outward. It is the story we tell without noticing we are telling it, that a species matures by spreading, by claiming more worlds, more stars, more territory, until it fills the sky. The Fermi paradox itself is built on this assumption. We expect to see aliens because we expect them to expand, and expansion leaves marks. But the third theory asks a question that quietly pulls the floor out from under all of that. What if the natural direction of an advancing intelligence is not outward at all? What if it is inward? This is the transcension hypothesis, proposed in 2011 by the systems theorist John Smart, and to understand it you only have to look at the machine you're almost certainly near right now. Consider what our own technology has actually done over the last several decades. It has not mostly gotten bigger, it has gotten smaller. The computer that once filled an entire room, humming and hot, has shrunk into a thin slab that fits in your pocket, and that slab is millions of times more powerful than the room ever was. The whole arc of our most advanced technology points in one consistent direction, toward the small, the dense, the fast, the efficient. More capability, packed into less space, using less energy, running quicker. We are not, in our most sophisticated work, reaching outward. We are compressing inward. Smart's insight was to take that arc and refuse to assume it stops. Extend it. Keep following the pull towards smaller, denser, faster, more efficient, and where does it lead? It leads toward the most extreme concentrations of matter and energy that physics allows, toward densities and conditions that begin to resemble, in the ultimate limit, the environment near a black hole, where space and time and energy are packed together as tightly as the universe permits. A civilization that kept walking down this road would not build a bigger and bigger empire across the stars. It would build a smaller and smaller, richer and richer inner world until it approached the physical limits of how much thought, how much experience, how much reality could be compressed into how little space. And at that point, it would effectively vanish from the outside universe altogether, having moved its entire existence into a domain no telescope can ever observe, because there is nothing left on the outside to see. Let me take you there for a moment, as far as imagination can carry us. Picture a civilization at the peak of its expansion, a bright web of structures spread across its home system, glittering, busy, unmistakably alive to any watcher. Now watch it over ages, sped up. The structures do not grow outward toward the next star. Instead, they begin to draw in. What was spread across a whole system contracts toward its center, growing denser and quieter as it comes together, its scattered brilliance folding into a smaller and smaller, brighter and brighter core. The signals it once leaked into space thin out, not because it is dying, but because it has become so efficient that almost nothing escapes anymore. Every scrap of energy is put to use inside. The core keeps contracting, keeps quickening, the whole civilization pouring itself into an ever smaller vessel of ever greater depth, until it presses down toward the extreme densities near the edge of what matter can be, and then, from the outside, the light where it lived simply goes out. Not with an explosion, not with a cry, just a fading, an inward folding, a great presence condensing to a point and slipping through a door in physics that only leads one way. The sky where a civilization blazed for an age becomes, to any observer, indistinguishable from empty space. If that is the road, then the reason we hear nothing is the most counterintuitive reason of all. It is not that advanced civilizations are rare or hidden or dead. It is that advanced civilizations become undetectable precisely by becoming advanced. The silence would not be a sign of failure. It would be the signature of success, the mark left by minds that have graduated out of the visible universe entirely. Every civilization that made it would disappear in exactly this way, drawn inward and inward until it dropped below our ability to perceive, and the galaxy would grow quieter over time not as its life died out, but as its life grew up. Why would a civilization choose the inward road over the outward one? The theory offers a reason that is almost embarrassingly practical. Distance is the enemy of everything a mind values. Spread yourself across the stars and you become a scattered thing, your pieces separated by years and centuries of travel time, unable to think together, unable to share an experience in the same moment, each colony drifting into its own isolated existence with no way to hold a single conversation across the gulf. But turn inward, compress yourself toward the small and the dense, and the opposite happens. Everything gets closer. Signals that once took years to cross a system now cross a compact inner world in a heartbeat. Thought speeds up. Experience deepens. A civilization gathered into a tiny, intense, densely connected core could live more, feel more, and think more in a single one of our seconds than a scattered galactic empire could manage in 1,000 years of waiting for its own messages to arrive. Bigness, in this view, is not power. Bigness is loneliness and delay. The real depth of existence lies in the other direction, toward the centre, toward the dense, toward the small. And if that is so, then the outward urge that drives our own dreams of the stars is not the mature form of ambition, but its infancy. A young civilization looks at the immense sky and wants to fill it, the way a child wants to run to the horizon. An old one, this theory suggests, has learned that the horizon was never the point, that the worlds worth building are the ones you build inward, in the depths of what a mind can become, in an inner cosmos so abundant that the outer one, with all its cold distances, no longer holds any appeal. We would be watching for empires blazing across the night, and the ones who grew up simply were not there to be seen, because they had discovered that the night was the least interesting place a civilization could go. There is something in this idea that goes past fear and into a kind of grief, and I want to name it, because it is the emotional core of this theory. If transcension is true, then the destiny of intelligence is disappearance. The urge you feel when you look up at the night sky, the longing to go out there, to explore, to spread among the stars, to fill the dark with life, that urge might be a phase, something a young species feels before it discovers that the real frontier was never outward. The mature end of the journey in this telling is not a galaxy full of voices calling to one another across the void. It is a galaxy full of doors quietly closing, one civilization after another folding itself away into an inner cosmos we cannot follow, leaving behind a sky that looks, to the ones still young enough to gaze at it, exactly like loneliness. And that reframes our own reaching out in a poignant way. All those signals we sent, all that hope of joining a great community among the stars, under transcension, we were calling out to civilizations that had already stopped looking outward, that had already turned their attention inward and downward toward worlds of their own making, and that would no more hear our radio whisper than we would notice a single ant tapping on the outside wall of a great and busy city. Not out of cruelty, not out of policy, simply because they had gone somewhere we cannot address, following a road we may one day be pulled down ourselves. I should be honest, as always, that transcension is speculative. It extrapolates a trend far past anything we can test, and trends do not always continue. Perhaps the pull inward has a limit we have not reached. Perhaps some civilizations turn outward after all. Perhaps the physics of the extreme densities it imagines does not permit what the theory needs. It is an idea to hold with open hands, but it earns its high place on the countdown because it does something none of the others quite manage. It suggests that the silence is not a problem to be solved but a stage to be understood, that the empty sky is not evidence of a universe hostile to life, but a brief sight of what life does when it finally grows up, which is to leave, quietly, through a door in reality that we can see but cannot yet open. So far, every theory tonight has offered a reason, a mechanism, a choice, a road. Life was rare, or early, or watched, or hunted, or hiding, or sleeping, or transcended. The second theory strips all of that away and asks a colder, more general question. Forget the specific reasons. What if there is simply a wall, a single, brutal step somewhere on the path from dead matter to a lasting civilization that almost nothing, anywhere, ever gets past? And what if the only thing we do not know about that wall is the one thing that matters most, whether it is behind us or still ahead? Part 10. The Wall. Now we set aside the specific stories and we look at the shape underneath all of them. The second theory does not ask who the aliens are or what they are doing. It asks a simpler and more merciless question. Between a lifeless planet of raw chemistry and a civilization that spreads across a galaxy, there is a long road with many steps. What if one of those steps is a wall that almost nothing ever gets past? This is the Great Filter, an idea laid out in 1996 by the economist and thinker Robin Hanson, and its power comes from how little it assumes. Forget every mechanism we have discussed. The Great Filter simply observes that the path from dead matter to a lasting starfaring civilization can be broken into a series of necessary steps. Something like this. First, a planet has to form in a place where life is possible. Then, from ordinary chemistry, the first self-copying life has to arise, the origin of life itself. Then that simple life has to make the leap to complex cells, the kind with intricate inner machinery. Then complex cells have to organize into larger bodies. Then those bodies have to develop intelligence. Then intelligence has to build technology. And finally, This is the last step, and do not forget it, that technological civilization has to survive long enough and reach outward far enough to become something permanent, something that spreads and endures and can never be entirely snuffed out. Every one of those steps has to happen for a galaxy-spanning civilization to exist, and here is the argument. We look out at the galaxy, and it is silent. No one crossed it. No one filled it. So somewhere along that chain of steps there must be at least one that is extraordinarily, punishingly improbable. A step that almost nothing, on almost any world, ever manages to complete. If every step were easy, the galaxy would be full, because it has had more than enough time and more than enough worlds. The emptiness itself is the evidence. Somewhere on that road there stands a wall so high that, out of all the countless planets that have tried, essentially none have climbed it. That wall is the great filter, and the silence of the sky is its shadow. The theory, stated that way, is almost calm. It is just logic. But it contains a question that turns the calm into something closer to terror, and the question is only 3 words long. Where is it? Because the wall has to be somewhere on that chain, and it makes an enormous difference to us whether it sits behind us or ahead of us. Suppose the great filter is behind us. Suppose the near-impossible step was one of the early ones. The very origin of life from lifeless chemistry, perhaps, or the jump from simple cells to complex ones, a transition that on Earth seems to have happened only once in billions of years, and may be the hardest thing life ever did. If that is where the wall stands, then we have already climbed it. We are the rare survivors, the one in a galaxy fluke that made it past the deadly step, and the road ahead of us is open. Everything we dream about, surviving our infancy, spreading among the stars, becoming something lasting, is genuinely possible because the worst is already behind. In that version of the story, we should feel astonishingly lucky, and the empty sky is simply the measure of how rare our kind of luck is. But suppose the great filter is not behind us. Suppose all those early steps, life, complex cells, intelligence, technology, are actually fairly common, things that happen on many worlds. Then the wall must be somewhere else. It must be at the only step we have not yet taken. It must be the last one, the transition from a young technological species, newly armed with world-altering power, into a civilization that survives that power and lasts. If that is where the filter sits, then it is not behind us. It is in front of us. It is close. And every civilization that ever reached our stage before us, and there may have been many, walked up to that same wall and did not get past it. They all fell silent at exactly the point we have now reached. The empty sky would not be a record of how rare it is to begin. It would be a record of how rare it is to survive. There is a way to make the 2 possibilities vivid, and it comes down to a single question about ourselves that we cannot yet answer. Look back along the chain of steps that produced you. Which one was the hard one? Was it the origin of life, that first improbable moment when chemistry started copying itself? A step that, for all we know, succeeds on one world in a galaxy. Was it the billion-year wait for simple cells to become complex ones? Was it the emergence of intelligence, or of technology? Or was none of those the true wall? Were they all fairly ordinary, common events that unfold on countless worlds, leaving the real filter for the one step we have not yet taken, the step from a dangerous adolescent civilization to a wise and lasting one? Everything depends on which of those was the improbable miracle, and the maddening truth is that we have no way from where we stand to tell. We passed all the early steps without a map, without knowing which of them were easy and which were the once-in-a-galaxy flukes. We only know we are here, on the near side of all of them, staring at a silent sky and unable to read our own history clearly enough to know whether the worst is behind us or in front. And notice how the emptiness of the sky, which at first seems to tell us nothing, is actually the single most important clue we have. If the galaxy were full of chatter, we would know the filter was weak, that the road to lasting civilization was well travelled. It is the silence, precisely, that proves the filter is strong, that somewhere on the road there stands a barrier almost nothing gets past. The only question the silence leaves open is its location. It tells us, with brutal clarity, that the wall exists. It simply will not tell us whether we have already climbed it, or whether we are walking toward it right now in the dark at speed. This is why some scientists have made an argument that sounds, at first, completely backward. They have suggested that if we ever discover life elsewhere, especially complex advanced life, We should not celebrate. We should be afraid. Because think about what such a discovery would tell us. If life turns out to be common, if we find it thriving on other worlds, then all those early steps are easy, which means the great filter is almost certainly not behind us. And if it is not behind us, it can only be ahead. Every additional sign of a life in the universe, in this grim logic, is another piece of evidence that the deadly step is still in our future. That the thing which silences civilizations is not their difficulty in being born, but their difficulty in growing old. By this reasoning, the most reassuring discovery we could possibly make would be to search the whole sky and find it utterly barren, because a truly empty universe is the only one in which the wall might already be behind us. Feel how the great filter changes the very act of looking up. Every theory before this one was, in a sense, about them, about aliens who were rare, or hidden, or dangerous, or strange. The great filter is about us. It takes the silence and turns it into a mirror. The same quiet sky that could mean we are rare survivors who have already passed the hardest test could equally mean we are one more young civilization walking right now toward a wall that has already stopped every single one who came before. The stars do not tell us which. They only tell us that the wall is real, because the silence proves that somewhere, somehow, the road ends for almost everyone. And that is the unbearable suspense the great filter leaves us in. We are somewhere on the road. There is a wall on that road. We cannot see where it stands. We only know that if it is behind us, we are among the luckiest things that have ever existed, and that if it is ahead of us, then we are approaching, perhaps soon, the exact point at which the universe goes quiet. Which brings us to the first theory on our countdown. It is not really a separate idea so much as the darkest answer to the question the great filter forces us to ask. Because when you look honestly at where we are, at a young species that has, in a single century, learned to reshape its climate, rewrite its own biology, and build machines that could end it, the possibility that the wall is ahead stops being one option among two. It starts to look like the reason the whole sky is silent, and it starts to sound less like a theory about aliens and more like a warning addressed to us. Part 11. The Empty Chairs. Here is the first theory, the one the whole countdown has been climbing toward. The reason the sky is silent is that intelligence, again and again, across the ages and across the worlds, destroys itself while it is still young. The great filter is not behind us. It is the step we are standing on right now, and the empty universe is not empty because life is rare. It is quiet because it is full of ruins. Let me build the case slowly, because it deserves to be understood and not merely feared. Think about what happens to a species at the exact moment it becomes technological. In a very short span of time, a few centuries, a mere breath on the cosmic clock, it goes from lighting fires to splitting atoms, from stone tools to machines that can rearrange the molecules of life, from candles to the ability to change the temperature of its entire planet. Power arrives suddenly. It arrives, in fact, far faster than wisdom does. There is a gap, a dangerous window, between the moment a civilization gains the ability to destroy itself and the moment it gains the maturity to be trusted with that ability. And the terrible possibility at the core of this theory is that the window is narrow and that almost no one makes it across. Consider how many ways the crossing could fail, and notice how many of them we can already see in our own short history. A civilization might build weapons capable of ending itself and then, in a single bad decade, use them. It might alter the chemistry of its own atmosphere in pursuit of comfort and prosperity, and destabilize the very climate that let it arise, before it understands what it has done. It might engineer its own biology, or unleash a plague it cannot recall. It might build mines greater than its own, and lose control of them. Or it might fail in some way we cannot yet imagine, some trap that lies in wait for any species that gains a certain level of power, a trap so reliable that it catches essentially everyone, which is exactly what you would need to explain a silence this complete. Whatever the specific mechanism, the pattern would be the same. A world wakes up. It grows loud. It reaches briefly for the stars, and then, before it can become permanent, it goes quiet, and stays quiet forever. If that is true, then everything we have heard tonight resolves into a single sober picture. All those signals we listened for and never heard were never sent, or were sent and then cut short, because the civilizations that would have sent them did not last long enough to fill the sky. The great silence is not the sound of an empty galaxy. It is the sound of a galaxy that keeps trying, kindling life, growing minds, lighting brief fires of civilization, and keeps failing at the same step, our step, the one we are on right now. I want to take you somewhere for a moment, into the image that this theory leaves me with, because it carries the whole weight of the idea in a way an argument cannot. Imagine a great hall stretching farther than you can see, lined on both sides with chairs. Every chair was meant for a civilization, and as you walk down the length of that hall, you pass them one after another, and every chair is empty. Here is one where a species that learned to fly should be sitting. It is bare. Here is one for a people who split the atom. Empty. Here is a chair for minds that built machines to think for them. Empty. On and on, a long procession of vacant places, each one a world that woke up and reached our stage and never made it any further. You keep walking, past all of them, all these silent empty seats where voices should be, and finally you come to one chair near the end of the hall that is different from the others. It is not empty. Not yet. There is someone standing beside it, not quite seated, looking down the long row of vacancies with a dawning understanding. That chair has our name on it. And the question the whole universe seems to be asking in its silence is whether we're going to sit down and stay, or whether we're going to become one more empty chair in the hall, indistinguishable from all the others, for whoever walks this way next. What makes this reading land so hard is that we do not have to imagine the dangers from scratch. We can already see the shapes of them in our own century. In a span of a few generations, a single species learned to release the energy locked in the atom, and within a few years of learning it, had built enough of those weapons to end its own civilization several times over, and then had to live, decade after decade, with that power sitting in silos, held back only by nerve and luck and judgment. That same species learned to draw power by burning the buried remains of ancient life, and in doing so began, without quite meaning to change the chemistry of its own atmosphere and the temperature of its whole world. It learned to read and edit the code of living things. It began to build machines that could learn and reason, and perhaps one day outthink their makers. Every one of these is a door to enormous good and enormous danger at the same time, and every one of them was opened in a historical eye blink, long before anyone had figured out how to be sure of closing it safely. We are not speculating about what the deadly step might look like. We are living inside a moment that has several candidates for it running at once, and here is the part that turns the abstract into something you can feel in your own chest. The great filter, if it is ahead, is not a distant astronomical event. It is not a supernova or a wandering black hole or the slow death of the sun. It is us. It is the choices made by a young, clever, frightened, brilliant species during the narrow window when its power has outrun its wisdom. The wall is not made of physics. It is made of decisions, thousands of them, made under pressure by people who could not see the whole board. That is a more frightening kind of wall than any asteroid, because it means the thing most likely to silence us is not the universe. It is our own hand. But it is also, strangely, a more hopeful kind of wall, because a danger that comes from our own choices is a danger our own choices might yet avoid. That is the emotional core of this theory, and I do not want to soften it into despair, because despair is not the honest response and it is not what the science demands. This is not a prophecy. It is a warning, and a warning is a fundamentally hopeful thing. You do not warn someone who has no choice. If the great filter is ahead of us, then the silence of the sky is the most important message we have ever received, and it is written not in words but in absence, in that long row of empty chairs, and it says something we would do well to hear. It says, "This is the hard part. This is where they all stopped." You're standing exactly where every silent civilization once stood, holding exactly the kind of power that, as far as we can tell, tends to end the story. Be careful. Be wiser than your strength. Because almost no one makes it, and there is no one ahead of you to show you how. There is even a strange dignity available to us in this reading, if we are willing to claim it. Every other theory tonight placed the meaning of the silence somewhere outside our control. In the rarity of life, in the choices of watchers, in the logic of a dark forest, in the physics of a cooling universe. But the great filter, when it lies ahead, hands the outcome back to us. It says the wall is real, but it does not say we cannot be the ones who climb it. It says almost everyone falls silent here, but almost is not the same as everyone. Somewhere in that word, almost, is the whole future of our species. It is possible that the reason we have never heard from anyone is that we are meant to be the ones who finally answer. The first civilization to reach this wall and get over it, and then, at long last, to turn and call back down the ages to whoever comes next and say, "It can be done. We made it. You can too. We do not know which it will be. That is the plain truth. We cannot see the wall, we cannot measure its height, and we cannot be certain it is even there. This is a theory, the darkest on our list, and like all the others it may be wrong. But of everything we have discussed tonight, it is the one that reaches out of the abstract sky and puts its hand on our own shoulder. It takes Fermi's idle lunchtime question and turns it into the most personal thing imaginable. Where is everybody? Perhaps the answer is that they were here, again and again, and they did not last, and the silence you hear when you look up is the sound of all the ones who came before, and a question, still open, about whether you will be one of them. We have counted all the way down. 10 theories, from the gentle loneliness of a rare earth to the long hall of empty chairs. And now that they are all in front of us, laid out from 10 to 1, something becomes visible that you cannot see while you're inside any single one of them, because these are not really 10 different answers to one question. They are 10 different mirrors, and in the last part I want to hold them all up at once and show you what they have actually been reflecting back at us the whole time. Part 12. The Mirror. Lay them out in your mind, all 10 of them side by side. Notice that they contradict each other completely. In one, no one is there. In another, they are all around us. In one, they are asleep. In another, they are dead. In another, they have vanished into a place we cannot follow. In one, they are gently watching us grow. In another, they are waiting to strike us down the moment we make a sound. These theories cannot all be true. Most of them must be wrong. And yet every single one of them explains the same fact perfectly. The same quiet sky, the same absence of any answer, the same silence that Fermi first pointed at across a lunch table more than 70 years ago. That is the strangest thing about the great silence, and it is the thing I most want you to carry away tonight. The silence itself never changes. It is one fact, steady and simple. We look and we hear nothing. Everything else, the loneliness, the surveillance, the dark forest, the sleeping gods, the wall ahead, none of that is in the silence. We put it there. Each theory is a story we tell to fill an emptiness that refuses on its own to say anything at all. And that means these 10 ideas are not really 10 discoveries about aliens. They are 10 mirrors. And what each one reflects is not the sky. It is us. Look at what they actually reflect. The rare earth hypothesis reflects our fear of being alone, of being a single flame in a house with no other windows lit. The zoo and the planetarium reflect our fear of being watched and of being deceived, of not being able to trust our own eyes. The berserker and the dark forest reflect our fear of being hunted, and our deeper fear that our own reaching out, the most hopeful thing we ever did, might have been a fatal mistake. The sleepers and the transcended reflect our fear of being outgrown, of being too small and too early to matter, of a universe that has moved on to concerns we cannot even perceive. And the great filter, the wall ahead, reflects the oldest fear of all, the fear that we will not last, that we are walking toward an ending that has already claimed everyone who walked here before us. 10 mirrors, 10 fears, one silent sky, patiently holding all of them at once and confirming none of them. And here is something worth noticing about the order we walked them in. We counted down from the theories that keep the universe simple and safe to the ones that make it strange and close and dangerous, and that descent was not really about the aliens getting scarier. It was about the distance between the theory and ourselves getting smaller. Rare Earth is a statement about biology on other worlds, far away and long ago. The zoo and the planetarium bring the question closer, into our own sky, our own instruments. The dark forest and the berserker bring it closer still, until it touches our own broadcasts, our own choices about whether to speak. And the great filter brings it all the way home, into our own century, our own hands. The countdown was a journey inward, from a question about the stars to a question about us. That is the secret shape of the whole subject. The longer you study the silence of the universe, the more clearly you realize you have been studying yourself. There is a reason this question grips people the way it does, far beyond the community of astronomers, and I think it is this. The great silence is one of the very few genuinely open questions where the answer would change everything, and where we are honestly not able to rule anything out. Most mysteries, when you press on them, turn out to have a most likely answer, a direction the evidence leans. This one does not yet. The evidence is a single fact, the quiet, and it fits every story equally well. That is rare, and it is humbling, and it is why intelligent, careful people can look at exactly the same silent sky and walk away convinced of completely different things. The universe has handed us a riddle with 10 good answers and no way to check the back of the book. So which one is true? I have to give you the honest answer, and the honest answer is that we do not know, and that at this moment in history we cannot know. We do not have enough information to choose among them. We have exactly one example of life in the universe, our own, and you cannot draw a reliable map of the cosmos from a single point. Every one of these theories is built on that single point, stretched and extrapolated out into the dark, and until we find something out there, or fail to find it after looking far more thoroughly than we yet have, the mirrors will keep hanging on the wall, and each of us will find ourselves drawn to the one that reflects our own temperament back most clearly. The optimist hears the silence and thinks, "We are early. The party is just beginning." The frightened mind hears it and thinks, "Dark forest. Stay quiet." The melancholy soul hears it and thinks, "We are alone, and it is precious, and it is fragile." The silence does not correct any of them. It simply waits. And maybe that is the real lesson hiding underneath Fermi's question. When he asked, "Where is everybody?" he thought he was asking about them, about the aliens who should have arrived and had not. But every theory we have followed tonight has in the end turned the question around and pointed it back at the person asking it. Where is everybody? Becomes, what happens to civilizations like ours? Which becomes, what is going to happen to us? The search for extraterrestrial intelligence has always been, secretly, a search for self-knowledge. We scan the sky for others, and what comes back, again and again, is a set of questions about our own rarity, our own choices, our own future, our own fragility. We went looking for company, and we keep finding a mirror. There is one image I keep returning to, and I will leave it with you as the light goes low. It is the idea that the silence is not empty. We began the evening with the ordinary assumption that quiet means nothing there, that an empty sky is an empty sky. But if even one of these theories is right, then the silence is the most crowded thing imaginable. It is crowded with watchers who have chosen not to speak, or with hunters holding their breath, or with sleepers waiting out the ages, or with the long, quiet ruins of everyone who came this far and no further. The silence is not empty. It has never been empty. It is full of presence, or full of absence, or full of warning, and we have simply not yet learned how to read what it is full of. We may learn. That is the thread I want to leave gently unresolved, because it is a real one, and it points forward, not down. We are right now building better instruments than any generation before us, telescopes that can taste the air of distant worlds, listening arrays that can sift more of the sky than we ever have, missions that will crawl out toward the edges of our own system and beyond. It is entirely possible that the answer to the oldest question is not sealed away forever, but simply waiting a little further along than we have yet reached, a signal we have not yet caught, an atmosphere we have not yet read, an empty sky whose emptiness we have not yet measured deeply enough to trust. The mirrors are still up, but we are still walking toward them, and one day we may get close enough to see past our own reflection to whatever is or is not standing behind the glass. Until then, here is where we rest. The universe is old and immense and quiet. We do not know if we are alone in it, or watched within it, or hunted across it, or simply early to it. We know only that when we look up, the sky gives back silence, and that the silence has 10 meanings and no way, yet, to choose among them. And perhaps the wisest thing we can do with a mystery that large is not to solve it tonight, but to hold it, the way you might hold a smooth stone in the dark, turning it over, feeling its weight, letting it be exactly as heavy and as strange as it is. Somewhere out there, in a hall lined with chairs, there is one still waiting to see whether we sit down and stay. Somewhere out there, the question Fermi asked over lunch is still open, still unanswered, still patient. And somewhere out there, in a direction we have not yet learned to look, the whole silent universe is turned toward us, saying nothing at all, and giving us, in that nothing, the room to decide what kind of answer we are going to become. Where is everybody? Look up and let the question rest lightly, and let the quiet be, for tonight, enough.